So we are now starting with the aromatic families. They are the aromatic hydrocarbons and the derivatives of aromatic hydrocarbons. So first of all we take aromatic hydrocarbons. Means benzene and its derivatives. So first of all we take benzene, then we take methyl substituted benzene, orthoxylene, metaxylene, paraxylene, mesylethylene, so this is our first member, it is benzene. Second member is toluene. Then we have orthoxylene, or it is 1,2-dimethylbenzene. Then we have metaxylene, paraxylene. This is vicinal mesylethylene. This is your symmetrical mesylethylene. So these were the mononuclear derivatives. Then we come to the polynuclear. Two benzene fused. This is called as naphthalene. This is alpha methyl naphthalene. This is phenanthrene. This is anthracene. These are the polynuclear derivatives. They are having two or more benzene in the fused state. Then we have families, aliphatic families. Number 3, halogen derivatives. Monohalogen derivatives. They are called as phenyl followed by name of halogen. Phenyl plus fluoride, phenyl fluoride. This will be phenyl chloride. This will be phenyl bromide. This is phenyl iodide. Then we have dihalogen derivatives. There are 3 classes: ortho, meta, para. This is ortho dichlorobenzene. This one is meta dichlorobenzene, this is para. Then we have hexa derivatives. There are two hexa derivatives. One is this system, another is derivative of benzene. They have formula C6H6Cl6 and C6Cl6. They are collectively called as BHC, benzene hexachloride. IUPAC name of this compound is 1, 2, 3, 4, 5, 6 hexachloro cyclohexane. This is 1, 2, 3, 4, 5, 6 hexachlorobenzene. These are hexa derivatives. Then we have in the same family we have side chain halogen derivatives. This is benzyl chloride, or this is called as phenyl chloromethane. This is benzyl chloride or phenyl dichloromethane. This is phenyl trichloromethane. So these are the side chain derivatives, halogen derivatives of benzene. And then we have the next family, that is phenols. They are having OH group in the benzene ring. We have fifth family, that is of phenols. A compound having OH group directly attached to benzene ring, they are called as phenols. We have monohydrate phenols and its derivatives. This is orthocresol, metacresol, paracresol. Orthocresol, this is metacresol, this is paracresol. Then we have dihydrate phenols having 2OH group at ortho position, meta position, para position. This is catechol, commercial name is catechol. This is resorcinol. This is quinol. It is benzene 1,2-diol. This is benzene 1,3-diol. This is benzene 1,4-diol. Then we have trihydrate phenols having 3OH group, adjacent carbon, they are having vicinal OH group. Then we have unsymmetrical phenol And then we have symmetrical phenol. This is called as vicinal trihydroxy benzene. This is called as hydroxyquinol, common name. IUPAC name is benzene 1,2,4 triol. This is benzene 1,2,3 triol. This is commercially fluoroglucinol. This is also known as pyrogalol commercially. This is benzene 1,3,5 triol. So these are trihydric. Then we have side chain derivatives. They are actually not phenol. They will be dealt as alcohols because OH group is present in the aliphatic chain. This is called as benzyl alcohol or phenyl methanol. So this is side chain derivatives. Similarly, we can have one more carbon here, CH2, CH2OH. This is 2-phenyl. Numbering would be done from OH carbon, 2-phenyl ethanol. So these are the phenols and derivatives of phenol. Then we have the next families, aromatic aldehydes and ketones. Aldehyde, benzene ring having CHO, benzene ring having CHO and OH group, benzene ring having CHO and NH2 group. This is called as benzaldehyde or benzene carbaldehyde. This is salicylaldehyde, or it is 2-hydroxy benzene carbaldehyde, 2-amino benzene carbaldehyde. Then we have ketones, benzene ring having CO group. This is diphenyl ketone, common name. IUPAC name will be benzophenone. This is acetophenone. Or phenylethanone, IUPAC name phenylethanone. So these are aromatic aldehydes and ketones. Then we come to aromatic carboxylic acids. Aromatic carboxylic acids, they are having COOH group attached directly to benzene ring. So this is our 7th family, aromatic carboxylic acids. This is called as benzoic acid or benzene carboxylic acid. Then we have 2 carboxylic group attached at 1 and 2 position. It is phthalic acid or it is benzene 1,2 dicarboxylic acid. Then we have meta isomer. This is commonly called as isophthalic acid or benzene 1,3 dicarboxylic or dioic acid. Then we have next isomer. This is terephthalic acid. And benzene 1,4-dicarboxylic acid. After this we have side chain derivatives. Carboxyl group attached in the side chain. This compound will be considered as a aliphatic compound. We are studying it with the aromatic carboxylic acid. So this is 2-phenyl ethanoic acid. Since it shows the property of aliphatic carboxylic acid, then we have the next system, derivatives of carboxylic acids, as we done in case of the aliphatic families. So we have 4 classes of the compound again. We have acid halides, we have acid anhydrides, we have esters, then amides. This is benzoyl chloride. It is common as well as IUPAC name, can be called as benzene carboxylic chloride also. This is benzoic anhydride. Or benzene carboxylic anhydride. This is ethyl benzoate or ethyl benzene carboxylate. This is benzamide or benzene carboxamide. So these are the derivatives of carboxylic acid. Then we come to aromatic amines, family number 9, aromatic amines. Benzene ring having NH2 group. This is primary amine. If it has 2 benzene ring, secondary amine. If it has 3 benzene ring, then it is termed as tertiary amine. This is aniline or aminobenzene. This is N-phenyl aniline. Here one system is aniline, 2 are substituent NN diphenyl aniline or aminobenzene. If we are having mixed amine, that will be having alkyl group as well as phenyl groups. Then aniline is the parent name. Its name will be N-ethyl, N-methyl aniline. Parent amine is aromatic amine. Alkyl groups, they are taken as substituent here. Then we come to side chain derivative. Similarly, in this family, side chain derivative will be dealt as aliphatic amine here. This compound is benzylamine. Whenever we are having CH2 in benzene ring, it is benzyl followed by amine, and IUPAC name will be phenyl methanamine, since it is a derivative of methanamine. So this is phenyl methanamine. Then we come to some other families. They are aromatic sulfonic acid, nitric acids, and then we have the aromatic nitriles. sulfonic acids. Benzene ring having SO3H. Common name is phenyl sulfonic acid. IUPACically benzene sulfonic acid. Then we have 2SO3H group. This is meta benzene disulfonic acid, or this is benzene 1,3 disulfonic acid. Then we have symmetrical system, SO3H, SO3H, SO3H. It is obtained on baking sulfuric acid and benzene. This is your symmetrical benzene sulfonic acid, and here we will call it as benzene 1,3,5 trisulfonic acid. Then we have 10 family aromatic nitro compounds. They contain NO2 group in benzene ring. Common name is phenyl nitrate. IUPAC name is nitrobenzene. Then we have meta-dinitrobenzene. We have symmetrical trinitrobenzene. It is used as explosive. This is commonly nitrobenzene or phenyl nitrate. This is ortho dinitrobenzene. It is symmetrical trinitrobenzene. Then we have side chain derivative that is considered as aliphatic system. It is phenyl nitromethane. This is nitro compounds. Then we have next family phenyl cyanides. Benzene ring having CN. This is phenyl cyanide or benzene carbonitride. Then we have phenyl isocyanate NC. Or phenyl carbylamine. Then we have 12th family, that is Grignard reagent. Benzene ring having MgBr. This is phenyl magnesium bromide, popularly known as Grignard reagent, used to synthesize almost all the organic compounds. Then we have BDC, next class benzene diazonium salts. This is benzene ring having N2Cl. This is benzene diazonium chloride. Similarly, we have one more compound like this, N2HSO4. This is benzene diazonium bisulfate. This is also a diazonium salt. They are used in the preparation of dyes through coupling reactions. Grignard reagent is highly important compound. It is used to synthesize organic compounds. So this is all about the aromatic families. Then we have one specific class of compound. They are called as Spyro compounds. How to name these compounds? Spyro compounds are those compounds, they are bicyclic compounds, but both of the cycle they are joined together by a single carbon. such systems, they are called as Spyro compounds. So the two cycles are there, but they are joined through a single carbon. So what are Spyro compounds? Let us write that. Naming of Spyro compounds. Now what are Spyro compounds? Spyro compounds consist of two rings containing carbon atom joined together by a common carbon atom. They are called as Spyro bicyclic hydrocarbons. Let us name some compounds. This is Spyro, followed by number of carbon in each cycle in a increasing order. So this cycle has 2 carbon each. 1 2 1 2, this is common carbon. So 2 2. Then we will count the total carbon. These are 5 corners. Therefore we will write at pentane. So before naming this, we will be writing Spyro. As we done in the previous case, we got bicyclo word before the bicyclic compound. Then we have next compound. So this is also a Spyro compound, and it contains carbon 4 in the first cycle and 2 in the second cycle. So they are written in the increasing order 2, 4. And how many carbon though? 5 plus 2, 7. This will be heptane. So this will be heptane. Then we have another cyclic compound. We have hexagon here, and on other side we are having a tricycle. So now this compound is again a Spyro compound. How many carbon? 2 and 4 again. 2 and 5. Then we have 7 carbon here. 3 and 1 2 3 4 5. 8 carbon octane. So Spyro compound, they are named like this. Spyro 2,5 octane. Then we have another compound. Now this is Spyro system, this is not Spyro system. So we'll be mentioning the numbers of these groups which are attached here. So in such cases the numbering is done first of all that of small cycle, and that numbering is started from the next carbon next to the bridge carbon 1 2 3. Then we go to this side 4 5 6 7. So 5 and 2 carbon, they are containing the dicyclopropyl group is there. So you will be writing 2 5 dicyclopropyl. Then we write Spyro, 4 carbon in this cycle, 2 in that, so 2 4. Then we have 7 carbon system heptane. So this is the way how we start the numbering. First of all, small cycle is numbered, then big cycle, and in this manner we come here. This is the compound. Here we are introducing a group, that is this group. Now first small cycle is numbered 2 3 4 5 6 7 8. 8 carbon system is there, and 5 carbon contain 1 2 3 propyl. So you will be writing 5 propyl. Then add Spyro here, and after writing Spyro, their number of carbons 2 5. Then it is octane. So in this manner substituted member, they are named as such. Then we have another compound. This is cyclobutane up to now. Now this cyclobutane, it is substituted with cyclopropyl. How to name this compound? Numbering should be done from the carbon, a small cycle to be numbered first. This compound is like this. If it would have been like this is not a Spyro compound. Now we are making it as a Spyro compound by doing so. This can be like this can be outside this figure. So numbering should be done first of all that of small cycle. It is 1, 2, then we